So just start it. Okay. So um, um, all right. So you can see the question, all right?
Yeah.
Cool. So I've just got two straight lines and they cross each other at Q. And you just told that the point Q is 1, 3 and R is 7, 0. And the length of QR is A root 5. Find the value of A. Okay, so how would we do that?
So what I did was I created this triangle that went 3 down and 6 across, and that should give the what's it called, the length of this side. That's what it's asking for, right? The length.
The length of QR, yeah, exactly.
So a squared plus b squared equals c squared. That's 3 squared plus 6 squared equals c squared, which is 36 plus 9 equals c squared, which is 45 equals c squared, which is 3
Okay,
root
yeah,
5
okay.
equals c.
Just in general, yeah. So Pythagoras' theorem, right? That's what we're going to do. We'll look at the detail in a moment. Yeah, okay, cool. The line L2 is perpendicular to L1 and passes through Q and crosses the y-axis at P. Find the equation for L2. So how would we go about finding the equation for the line that's perpendicular to
I think
QR?
I would find the equation for QR, the line QR, and it's because it crosses, it's perpendicular, so it'll have an opposite gradient. So what you can then find, and you have the point Q, so that you can write the equation of L2 then.
Yeah, do we need to find the actual equation for L1?
No.
Okay, what do
You
we
already
need?
have the two values you already have the values 3 and 6, so you can just do rise over run, which gives you the gradient of L1. You find the reciprocal and then use that to find the formula for L2.
Exactly, yeah. So remember I always said about these types of questions is just draw the triangle. Yeah. So there's about 15 formulas you could use, but don't bother with any of those. Just draw a triangle. If you draw a right angle triangle, yeah, you immediately get the length QR, but you'll also get the gradient as a freebie because you can easily figure out the gradient from it. And yeah, exactly. Once you've got that gradient, you can figure out the gradient of L2. You've got a point, so then you can find the equation. The coordinates of P, if you know the equation of the line, you're going to know the coordinates of P, aren't you?
Yeah.
So what would that be from the equation?
0. So you set x to 0.
Yeah.
That should give where it crosses.
Is there any way of knowing what the coordinate of P would be without even doing anything?
It's the cut.
Right, exactly. It's just in the equation, isn't it? Plus C of the equation will be P. And then we'll do it now. We'll have a look at the area of the triangle PQR. So we know the length L1, and we know it's perpendicular. Okay, that's how we go. Just thinking the best way to do it. Yeah, why don't you do the question yourself, Ollie? So have a go at finding the value of A, and I'll do it after you. So can you see that? Okay.
Yeah.
So draw a picture, draw a sketch, and do Q. On the length. How's it looking?
Think I've got it.
Yep.
Equation of the line should be y is equal to minus a half x plus 7/2.
Okay, but that's not on the question. The question is how long is the line QR?
Sorry, I was doing different thing. Oh,
That's okay. So you found the equation line, that's all right. So you found the gradient was what?
minus a half.
Was that okay? I'm in agreement with you there. That's actually part B we're gonna look at. And we said we don't want to remember we said we didn't need an equation for L1.
Yeah.
Okay, so let me show you what I've done. So there's the graph.
Yeah.
There's a sketch. Drawn a line vertically down from 1, 3, and it's got a height of 3 because it starts at 0.
Yeah.
And width is 6 from 1 to 7. So just using Pythagoras, the length of the hypotenuse will be 9 plus 36. We use the square root of 45, which is a rectangular number. So it's 3 root 5. So that's our answer. A is 3 because we wanted to write number times root 5. Okay, so now part B. We need to find an equation for L2. So here, what we want is the gradient of L1, which you've already found, which is minus a half. So what would be the gradient of L2 then?
Two.
2, yeah, which has a kind of feeling of truth about it because it looks fairly steep. It looks like a 2, you know, from what we've seen before. It can't be exactly like that, but you can see it's a positive gradient, and it's fairly steep, which is what 2 is. Okay, so what would the equation be? So have a go at that for a minute. Figure out the equation.
Okay.
Yep, far away.
Y is equal to 2x plus 1.
Yeah, exactly. Yeah, that's what I got. So y equals 2x plus c. We know the it goes through 1, 3. So yeah, y equals 2x plus 1. My favorite straight line. That's the one I always use. We've seen that before. Hopefully that's familiar to you. Y equals 2x plus 1. It is to me. I see it every day. So where would it cross the what's the coordinates of P then? Where does it cross the y-axis?
0, 1.
So it's going to be 0, 1. Okay. So the final question is find the area of this triangle. So PQR. So we'll draw a line from P to R. We want to know what the length of this is. So any ideas on that, Rahat? What did you try?
PQR, so the area. So I drew out the triangle, and then I tried to break it down and try to find the lengths of the different. I tried to break it down to right triangles and find the lengths of the different sides, and I thought that could give me the area, but
Yeah,
we
well, that sounds right. Yeah. So this is QR. We've established is 3 root 5, and all we need to know then is this PQ, because times those two together we'll get a rectangle, but we divide it by 2, we'll get a triangle. So we just need to find this length here. Now we know we just got you to find the coordinate of it. So 0, 1. So the width is 1. So again, draw a triangle underneath, by the way, yeah. Draw another triangle. And the width is 1, and the height is 2. From 0 to 1 and 1 to 3. Yeah.
Yep.
So what's the length of the line going to be? PQ?
2 squared plus 1 squared, so 5.
It is 5, and then what do we do with the 5?
So 5 will be the length of that side. Okay, so we have the length on the side.
No, what do we do with the 5? There's no way that length is 5. What is it?
Root 5, sorry, root 5.
Root 5, exactly, yeah. Yeah, so square root of 5. And also often in questions you get this, where you notice that the side is root 5 and the other side is 3 root 5, which is quite neat. You know, sometimes it's kind of a little bit of neatness because we're going to multiply those together now. So the area is going to be 3 root 5 times by root 5 over 2. So the root 5 times root 5 is going to be 5. So that's 15 divided by 2. We don't have a unit, do we? Per unit? No. So we could say 7.5 square units. Does that make sense? Yeah, because that's what you're trying, isn't it? What is that? What you got, Rahat?
No, I got some. I don't know what I got, but it wasn't that. Where is it? My answer is somewhere. But I think I did it more than once as well. So
You're trying to find the length of everything. I think it sounds like you're trying to find the length of every possible thing going. But
okay,
for a triangle, we just need the height and the base, don't we? Or the height and the width.
So you have root 5, 3 root 5, and you have root 5, which is the base. Not is that the base height?
Yeah, because they're perpendicular to each other, aren't they? Because we've established that this is perpendicular because it says it's perpendicular. So PQ to QR. So it's just an upside down.
The length of this line below, the one that joins the points P and R, that's the base. So base times height divided by 2. For this.
I'm just gonna reset my camera. I just noticed I'm frozen. Looks strange. Okay, doesn't want to do that. Oh, there you go. Yeah, so yeah, it's essentially it's a triangle, you know, right? Well, it's times 2 height by the base, yeah. It's the rectangle in disguise, and we're just going to halve it afterwards. You know, they're always trying to sort of guide you in that way. So that even with part C gives you gives you a hint because you need that number to figure out what the length of PQ will be. So
yeah, I thought this line that joined P and Q, sorry, P and R was the base. It's not, is it? It's this line at the top.
Yeah, because it's perpendicular. Yeah. Two perpendicular lines. So it's looking upside down to what we might normally work with, but that doesn't change anything. That's just perspective.
Okay.
Okay, so that's the question. Okay, so that's a typical straight line type of coordinate geometry question. We haven't really used any fancy formulas there. With equation of a line, Pythagoras, bit of a triangle. Okay, there are more, and also gradients, I suppose. There's a formula for gradients as well. But notice that we didn't use any of those. You know, there is actually, if you look in a textbook, there's a formula for the gradient, which you sometimes use Rahat, which I don't like. The y2 minus y1 over x2 minus x1. Just don't use that. Just draw a triangle. Okay. Straight line equation. I haven't even taught you the formula for that because I don't like it. You don't even know there's one that exists. I bet. So use y equals mx plus c. There's actually a formula, believe it or not. Pythagoras' theorem, yeah, I didn't formally use it, as in the sense I didn't write down a squared, c squared equals a squared plus b squared. Just bit more intuitively, just wrote the answer down. And area of a triangle, which is just base times height for a rectangle, and then halve it. Okay. So normally, if you look this up, you just see a bunch of formulas, but hopefully this is more intuitive, and we just draw a picture, point at it, and say that must be the answer. Okay. Cool. Okay, so let's have a look at the next one, which is about circles. So you got an equation here. You got an equation for the circle, and what's the point of algebra?
Where two lines meet.
Yeah, two lines, a line and a curve, curve and a curve, line and a circle, anything. But of course, it also tells you what.
What was that question? Sorry.
What's the point of algebra? Yeah. So what's the point of algebra?
Oh, if they don't cross as well.
Yeah, it'll also tell you if it don't cross. Yeah, so you can find out if two lines cross, but it'll also tell you if it doesn't cross. And this is an example of a line crossing a circle or not. So part one, it says state the coordinates of the center and the radius. So what will be the center of the circle?
5, 2.
5, 2. Just the x coordinate and the y coordinate. Sorry, the x value and the y value in the brackets. And the radius would be?
Square root of 20.
0, 20.
Did it ask for the radius? Oh,
Yeah.
it did. Yeah.
Yeah.
I was wondering why you just get 2 marks for writing down 5 and 2. Yeah. Wow.
Yeah, you got to read the question. Yeah. The question is everything, you know. Sometimes people read a question and assume they're asking something, but never assume. Read it and do what it says. Simple sort of thing to say, but people don't always do it. State whether or not this circle intersects the y-axis. So how would you figure that out?
Okay. I'm not quite sure the method I use, but I'm substituting 0 in for x in the equation because y meets the circle meets y when x would be 0, and then you sort of rearrange until you get a quadratic of in terms of y, which is y squared minus y 4y plus 9.
Yeah.
And then what I did was
There should be one or two solutions, and you can see by the discriminant if there is.
Right.
I did b squared minus 4ac,
Yes.
and that gave me minus 20. Shows that there is no solution, because if it's a minus number, then it shows that there's no solutions.
Absolutely. That's the perfect textbook answer. Yeah. So you find that you get a quadratic out of it, if x is 0. Try and solve the quadratic. There are how many kinds of quadratic are there?
3.
3. And what are they?
The one the discriminant is greater than 0, 0, or negative.
Yeah, which in plain English.
It has 2 solutions, 1 or none.
Right.
Or no.
It's either going to cross the x-axis twice, once, which is the square, but it kind of kisses it, which can be regarded as 2 solutions, or not at all. So here we've got a quadratic, and it's not going to cross. It's saying, is it going to cross the y-axis or not? And if the discriminant is negative, that's the 0. That's the 0 solutions scenario. So from what Rahat said then, it comes out as a negative. Yeah.
Okay.
Therefore, no. Is there any other way, more intuitively, to figure out whether or not the circle crosses the y-axis? And you're thinking intuitively? Because can't we just draw a picture?
Yeah.
We know where it is, and we know how big it is. So
We love for the question, if we drew it and we should look really far away from the y-axis, would they accept that?
yeah, logic, isn't it? Because let's draw it. Yeah. So we my axes are green. So The center is where?
5, 2.
5, 2. Okay. So that's there, 5, 2. And how big is the radius?
Root 20.
Root 20, which is that, well, for it to hit the y-axis, it needs to be at least 5, doesn't it?
Mm.
So is root 20 more than or less than 5?
Less than.
Less than 5, yeah, because root 25 is 5.
Yeah.
So 20 must be 4 point something, 4 and a bit. So it's less, isn't it? So it's not going to touch it.
No.
That will suffice. Yeah, that's fine. If you make that argument, the gradient is the radius rather is less than 5. That'll do. So either or there. So notice it's only 2 marks, so you don't need to do all the world's algebra. Yeah, that's fine. Cool. Find the equation of the line parallel to the line y equals 2x that passes through the center of the circle. So this is really just another straight line equation question. So if the equation of the line parallel to the line y equals 2x, what will be the gradient of this line that's parallel to the line y equals 2x?
Should be identical.
Yeah, it's 2, isn't it? And if you know the center of the circle, that means you know a point it goes through, don't you?
So y equals 2x minus 8. That was my final answer for this.
y equals 2x minus 8. Okay, yeah, okay. So I won't go through the same thing. Y equals 2x minus 8. That's fine. Let's make a note of that. Okay, so the final part is show that the line y equals 2x plus 2 is a tangent to a circle. To the circle, state the coordinates of the points of contact.
It basically touches the circle.
Yeah.
So you want to substitute y in to the circle's equation and then just solve. You should get a quadratic.
Yeah.
So and then the solution to that will be where it crosses, basically.
How many solutions will the quadratic have?
1, 2, or none.
Which one is it of those 3?
1. In this case, 1.
Why 1?
Because it's a tangent, so it would just touch the 2 lines would just touch. There's only one solution.
Exactly. So this is back to the old what's algebra for? What's the point of algebra? We've got a line crossing a circle, but it's only going to touch it once. So that screams, or should scream to us, a quadratic, which has got only one solution. So it'll come out as a square. The squares are the ones that have got one solution. Yeah. So let's just do the algebra for that. So we've got the, just make a note of the equation. So it's x minus 5 squared plus y minus 2 squared equals 20. So we want to see if y equals 2x plus 2 is tangent. So we substitute that in. So I'll just expand that. So x squared minus 10x plus 25. Y equals 2x plus 2. Oh, that's handy then, isn't it? Because it's 4x squared then, because minus 2 plus 2 is going to be 0. So it's just 2x squared. Minus 20 equals 0. So that gives us 5x squared minus 10x plus 5 equals 0. What's the next step?
Take 5.
So that, you broke up there, say that again.
You can take out 5 to make it simple.
Right. Exactly, yeah. Take the 5 out, factorize it. So x squared minus 2x plus 1. Next step.
Right side then should equal 0 because 5 times 0 is 0.
Exactly, yeah. So what's inside the bracket must be 0 because 5 is not 0. So it must be the other thing. So the quadratic is 0. So
X is 1 because it's, I just know it because it's a really simple quadratic.
Yeah, it's a square. Exactly, it's a square. It's x minus 1 squared, isn't it?
This is slightly different from what I did because I got 5x squared minus 10x plus 5, but then I did b squared minus 2 4ac,
Hmm.
and that gave 0. So I thought that showed that I had only one
That's okay.
solution.
Yeah, that's fine. That's okay.
So is there a particular reason why we're completing the square, or
Well,
we're just
I'm not. Well, I am completing the square because it's a square, but I've actually, you could say I factorized it as well. But if you complete the square on a square, it's similar. It's the same as factorizing it because it's a square.
So any reason why we're factorizing it instead of just using the discriminant? Because
That's fine. Yeah, that's fine. You can do either. So we've solved it, and we've got only one solution because it came out as a square. Or you could use a discriminant. Probably using the discriminant is slightly what I might call more mathematical, because we don't necessarily need the solution. We just have to show that it's a tangent. So you've done that better, really, Rahat, yeah, by doing that. That's a better way of doing it, in all honesty. But of course, I like it because it's come out as a square. That's also why discriminant is 0, because the square quadratics have 0 discriminant. So it's the same argument. Either way. So yeah. So as you know, there's sometimes more than one way to do stuff. I'd like it if you'd factorize it though. Did you factorize it beforehand, or did you just go straight into the b squared minus 4ac?
factorizing as in
The 5, take the 5 out. Common factor, isn't it?
no, I didn't really see the reason why. Should I have?
Yeah, well, only because the numbers are a bit lower. Yeah, so you take the 5 out, because otherwise you have to do 100 b squared minus 4 times, so it's minus 100. So it's just that if it makes, in general, for the next question, if the numbers are high and you can take out that number, it just makes it a bit easier to do.
So in this case, you got x plus 1, and that shows. So that shows that there's only one solution. Oh yeah,
Yeah,
you got
so,
only
yeah.
one solution, meaning you got only one solution, which is x plus 1. So this tells you that there is only one solution. It tells you where that solution is. Okay.
Yeah, as we know, if you there are two more sort of overarching types of quadratic. Either it's going to be a rectangle or a square. So if you get x minus 1 squared, it's a square, and they all sit on the x-axis. So x squared, for example, is a square. Sits on the x-axis. So x minus 1 squared is that x squared moved to the left or to the right? X minus 1 squared, left or right?
To the right, no?
To the right? Yeah, because remember, it's what x is that matters. So x is going to be 1 minus 1 is going to give the 0. So x minus 1 squared is x squared moved to the right. We talked about that in the previous lesson about completing the square. That's how we move stuff like right and left if it's in the bracket.
I remember talking about this using I thought it was circles, but okay, yeah, completing the squares.
Well, yeah, but that's the same thing, isn't it? X minus 5 squared is going to move x squared to the right 5. Y minus 2 squared is going to move y squared up 2. That's why it's got the coordinate 5, 2. Because it started off as the Pythagorean one, just x squared plus y squared, and then goes 5 to the right, 2 up. So where's that come from? It comes from completing the square, and it comes from translations. So yeah, so we see that this is just the x squared moved to the right one, and it still maintains one solution with a minimum of 1. X is 1, solution of 1. So it's only got one solution. So whichever way you do it, you're proving the same thing. So that demonstrates across once. That's it. Any questions on that? No.
No.
Yeah, so that I think that's fairly straightforward stuff, and I just wanted to sort of show you two nice sort of general questions, which are fairly typical of those topics. But they also touch on, the ideas of algebra. What's the point of it? Trying to find out where two lines cross. And in particular, that question has got show where two lines don't cross and show where two lines cross. So I just thought that was quite neat. Okay, so we'll leave it there for today.